Hello students, I am Pushkar, Master Teacher, Chemistry at Vedantu. I am discussing few problems in JEE Advanced 2020 Chemistry Paper 2. Let's solve this problem. Question number 13, numeric type. A solution of 0.1 molar weak base is titrated with 0.1 molar strong acid HA. During this titration, the variation of pH is shown in a graph, as you can see. On the graph, you can see the volume of HA on the x-axis and the pH on the y-axis. Volume of HA is a strong acid, and what is asked? The pKb of the base. Now the graph is giving you the information and everything you have to read from the graph. As you can see the graph, so in the graph, you'll find that the graph is initially like this, then it is getting straightened up, and then it is going like this. So meaning of this is straight line is that the titration is complete at this point. And if you check this point, this is coming at the volume of 6 ml. The volume of 6 ml. So the 6 ml is the equivalence point. 6 ml is the equivalence point. And if 6 ml is the equivalence point, the halfway, that is 3 ml, must be half equivalence point. So that is a typical titration curve. So on the graph, if you see, add the 3 ml, if you just take this line here and join it on the y-axis, what you will find? 11. That means this is the pH is 11 when 3 ml of strong acid was added. The meaning of this is that pH at half equivalence point is equal to 11. Now from this information, you have to get the pKb of the base. Can you do it? Yes. So the funda of this problem is how to approach this problem. You can approach this problem by using Henderson equation for buffer. And Henderson equations are pH is equals to pKa plus log acid in the denominator and the conjugate base in the numerator, or POH is equals to pKb plus log base in the denominator and conjugate acid in the numerator. So now choice is yours, which equation you would like to use. Since the graph is against pH versus volume of HA, it makes sense that we can use the first equation. But if we are quite accustomed to solving the problem for the basic buffer, so-called basic buffers or the titration of base, but this one, then you should take the second equation. So let me solve it by both methods, and choice is yours. So what method you like more? So let us solve it by first method. So the basic equation is B base is treated with H plus ion strong acid. It is getting converted into BH plus. So this BH plus is conjugate acid, and this is base. Okay. Using the first equation, pH is equals to pKa, of course pKa of BH plus log of, since we are talking about the pH, in Henderson equation, in the denominator you have the acid, and acid is the concentration of BH plus, and the salt is the concentration of B. At the half equivalence point, however, the concentrations are equal and log 1 is equals to 0. So of course this term will vanish because this is equals to what? 0. And you will get pH is equals to pKa of BH plus, that is conjugate acid of base, and you can learn from the graph that pH is equals to 11. So we got pKa of BH plus is equals to 11, and this gives us pkb of b is equals to 3 using the relation pka of an acid plus pkb of the conjugate base is equals to 14. Using this relation, we can justify this method, and let's call this method number 1 using the Henderson equation for an acid. Now let us solve it by Henderson equation by a base. So in this case, we'll write POH is equals to PKB plus log. In the denominator, we'll write the base, which is B, and in the numerator, we'll write BH plus. And eventually, this term is going to be what? 0, because BH plus is equals to B at the half equivalence point. So this term is ultimately going to be what? 0. And you are going to get POH is equals to PKB. But now to get the value of PKB, we need POH at the half equivalence point. And we can get it from this formula. pH plus POH is equals to 14. Since pH was 11 at half equivalence point, so 11 plus POH is equals to 14, and that gives POH is equals to 3. Substituting in this equation, we get PKB is equal to 3. So by both methods, you are going to get the same answer, of course. So I think this question is going to give you, the way I have solved it is also going to give you, clarify your doubts, as well as to give you a concept that you can use Henderson equation, one single Henderson equation, for calculating or estimating pH of weak acid, weak acid buffer, as well as weak base buffer. So I hope that you like this solution, you enjoyed this solution, and for details of solutions, you can also have these slides with you. Thanks for watching, and for more detailed account of these solutions, log in to Vedantu portal. Thank you for watching.